Hi, we are Engineering Brothers, and once again we have got our another S-plane plot over there. And according to our analogy, we do know that according to the position of our poles, we can do make a comment on the stability on that given systems over there. And let us just analyze once again what seems to be the transfer function in this case. Quite naturally, we do know that our transfer function seems to be Cs by Rs. And what is that point over here? You can see that from 0, this is our 1, and this one will be our plus 1, rather J1, and this one will be our minus J1. Okay. Now, what is the considered point in this case? Quite naturally, according to our S-plane analogy over here, 1 divided by, according to our pole, the pole location seems to be this one, which is S. This one will be our minus 1 plus J1 S minus 1 minus J1. And let us just check whether this is the correct position according to our diagram over here. And how do you get to that considered analogy? Just by making the denominator part that equal to 0. Now quite naturally S minus 1 plus G1, that is equal to 0, and according to our analogy we have got S is equal to 1 minus J1. And which one is our 1 minus J1? This point over here. This one will be our S1, and for our another point, just by making our denominator part that is equal to 0 in this given ratio, the another location of our pole seems to be S minus 1 minus J1, that is equal to 0. And once again S is equal to 1 plus J1, that one will be considered as our S2. Which one is our 1 plus J1? This one will be 1 plus J1. Now this pole position that has been reflected by this, and in our previous analogy or in our previous equation we are having 1 minus J1, that is reflected this pole over here. And these are our complex conjugate over here. Why? Because you can see that this one is 1 minus J1, this one will be our 1 plus J1. So this is the form of our complex conjugate, and both the poles are placed at the opposite side of our given axis over here. If you just put a mirror on this point, you will get the another inside our mirror, you will get to see the another poles over there, and that is the definition for our complex conjugate pole plotting for our S-plane consideration over here. Now we should consider, or we should solve this given equation, and let us just consider next steps over here. Quite naturally, if you just do solve this given equation, first we have plotted this much needed poles over there, and we have configured our equations over there, and no other textbook will like to give you this type of detailed analogies over here. So I always do like to say that if you do follow our Engineering Brother classes, you will get additional benefits, and your concepts will be crystal clear after that. Okay. Now just by solving our given equation, what we have got, this one will be once again the form of, we are having A plus B and A minus B. Okay, and the formulation will be S square minus B square. And in this case we do know that the A will be our S minus 1 and the B will be our G1. Now just considering or putting this in our given equation, we are having at the place of our A, we are just going to replace that is 1 S minus 1 squared, and this one will be our minus of G1 squared. Now we should solve this given equation over here, which is quite naturally our S minus 1 squared plus G1 squared, sorry, minus of G1 squared. Okay, and once again we do know that j is equal to square root of minus 1, and if you just make it squared, that is j square. This one will be our minus 1 over here. Now quite naturally the equation will be our s minus 1 squared plus 1 squared. Okay, now instead of considering this equation, we have shown you how to get or how to solve these given equations over here. Now at this place of our denominator, we are just going to put that over here, which is our s minus 1 squared plus 1 squared over here. Okay, now in our left hand side we are having our cs divided by rs, and once again we do require to consider the input as our impulse response over here. And what is the formation? The formation for our present consideration will be, if you just do consider the impulse response in this case, we can say that the input in this case will be our rs, and as we are taking the impulse response over here, the rs will be our 1. Okay, now quite naturally, because of this impulse nature of our considered equation, we are having cs is equal to 1 divided by s minus 1 squared plus 1 squared over here. Now once again, if you just do apply the inverse Laplace consideration in this given equation, now applying, once again we do require to apply inverse Laplace consideration, inverse Laplace on this given equation. We are having, ultimately we are having the CT format over here, and the inverse Laplace of this given equation will be our e to the power t sin t. Okay, and the next step will be quite naturally the simpler one. Just by following this waveform, we do require to plot that, which is ct versus t over here. And if you just do plot that in our ct versus time curve over there, you can see that the oscillation is increasing over here. You can see that the oscillation is increasing with respect to time. If you just do say that time tends to infinity, the oscillation is increasing with respect to time. That actually do give us the unstable system over there, and we can say that the state system is unstable over here. I have shown you how to consider this type of, just by looking at this S-plane, how to consider or how to make that as our stability considerations over there. I am just going to reconsider over here once again. First, just by looking at our position of our poles, we do require to form the given equation, which is going to be our transfer function over here. Now quite naturally, according to our definition of our transfer function, we do know that cs divided by rs, which is 1 divided by this one, as we do know that the pole is placed at the denominator of our given ratio over here. And just by looking at these given poles, we have considered those points over here, and quite naturally I have shown you how to get to that point over there. And just by looking at that given positions of our poles over here, we have formed this one as our considered point over here. And after solving this one, the equation seems to be this one. And once again, if you just do apply the impulse response on that given stability criteria, stability analysis, in this case we are having that the cs is equal to this one. And at the last stage, if you just do apply the inverse Laplace on this given equation, we are having ct, and ultimately we are having the time domain equation as e to the power t sin t over here. Now at the last stage, we should plot that over here, which is ct versus time over here. And after we have plotted that, if you just do increase the time, that is time t tends to infinity, the oscillation is keep on increasing with respect to time. And that is the ultimate nature or characteristic for an unstable system over here. Why? Because the plot do have the oscillatory nature, and there is the tendency to go to the infinite value over there, and we cannot get any sort of finite value in this oscillatory nature curves over there. That is why I can say that the system is unstable over here. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos, and keep following our channel. That's it. Thank you and goodbye. If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.